Okay, so next page. Rewrite the following expressions as a single logarithm. Just in case you didn't know, that's 3 and this is 2. We want to write them as a single. Now, not both of them, not all 5, but this problem we want to write as a single logarithm. And this problem we want to write as a single logarithm. Well, we're going to go back to those logarithm rules. And right here, we're going to use rules 1, 2, and 3. We already spoke earlier about rule 1. Really? That's what we're going to do? About rule 1 and rule 2. So rule 3. Rule 3 applies to this right here. So if I look at, say, this right here, 2 times log of 5. When I have a number in front of my log that's being multiplied, I can take that and change that to an exponent of what I'm taking the log of. So log base 5, or not 5 base, sorry, log of 5 to the second power. So that's my third rule. So I'm going to use that. So here we go. What did plus do? Well, if I've got two logs that are being added together that have the same base, what I can do is I can change them to one log by doing multiplication. So I'm going to take log. Well, first off, I need to do this first. Okay, so I'm going to do this first. I'm going to make that log of 2 to the second power. And then I'm also going to do this one, although we're going to wait. That's going to be log of 25 to the 1/2 power. So now, then I'm just going to have log of 3 plus. So I dealt with this 2 and this 1/2. I let the negative stay, and I'll show you why in a minute. So not first, I'm going to focus on, let's not do that. I'm going to focus on this. So I'm going to have log base 3. I keep saying base 3. I'm so sorry. Log of 3 plus log of 4 minus, what's 25 to the 1/2 power? Remember what fractional exponents do. Fractional exponents change your stuff to radicals. So the base is going to be 2. So it's the square root of 25. Square root of 25 is 5. So now we're going to deal with these two. So I've got log of 3 plus log of 4. They got the same base. That's this right here. These two added become log of 3 times 4. So I can do that. So now, because I've got log of 3 times 4 minus log of 5, that's where this comes into play. Because I've got the one log and then the other log, they're being subtracted. So that's going to be log of 3 times 4 over 5. So that's going to be log of 12 over 5. Okay, there we go. And now I had 3 logs that became 1 log, and that's my answer. So now I'm going to do the same thing over here. You know what? No, you get to do the same thing. It's the same principle. You go ahead, you go for it. So now I got number 10, which takes me to breaking down these trigonometric functions. Let's see. Do I got something about trigonometric functions? Come on, Lucky Notes. Do I got trigonometric functions? Okay, yep, here we go. What's that, the third page? So let's write it right here. So I've got y equals a times sine or cosine times b of x plus, nope, not plus, minus c plus d. So what did we say? Well, amplitude is a, frequency is b, the period is 2 pi divided by b. The phase shift is c, and then the vertical shift is d. So I'm going to start with this one, and then I'm going to do this one, and then I'm going to leave the first one for you. So first off, amplitude. Amplitude is always positive. So it doesn't matter that it's -2. I've said it was always positive a bunch of times, and folks didn't want to do it. So anyway, that's positive. I also forgot that if you look at, see, here's another one that we did. Now this one just takes you straight through the equation. I left a few example problems on the notes. So like this one right here. Let's see, I think let's see. That yeah, right here for trigonometry stuff. I got a couple of spots for examples there. I've got an example right here. I've got an example right here. And so I got a couple examples. Sorry, my fine wife just walked by and I had to stop and look. Shoot. Um, thank you, Lord. I'm married up. So anyway, so what am I gonna do? So like I told you, for this one, -2, nope. Amplitude is always positive, so that's +2. Next, the frequency. There's no number right here. No number right there means the frequency is 1. And if the frequency is 1, the period is 2 pi over 1, which is just 2 pi. Yippity doo dah. Okay? Phase shift. Phase shift is the plus or minus thing that is inside the parentheses, and it ain't in there. So I put an NA. And I marked people off because they didn't read the directions. Write none or N/A for transformations that don't exist. If you put 0, I'm going to mark it wrong. Read the dang instructions. And then last but not least, vertical shift. That's the number outside of the parentheses at the end. That's my D. Well, this is -1, so that's -1. Boom, I'm done. Yeah. And evidently my kids playing this game are making all kinds of noise. You don't need to make all that noise. Thank you. So next, what do I got? What's the amplitude? There's no number there, so it's 1. Frequency. Now this one is a little tricky. I'm going to just tell you ahead of time that you're probably not going to see one of these on the final, but I want to explain it anyway. The thing is, if you look at this, see the B, the frequency, is on the outside of the parentheses. So what do I do here? I want that 2. I want that 2 on the outside. So I'm going to distribute it, or I'm going to do the opposite of distributing. I got 2x plus pi, right? So if I pull out a 2, that's like dividing a 2, so that's just going to be x. But see, there's no 2 here, so what am I going to do? What does pulling out a 2 actually mean? It means I'm dividing by 2. So I'm going to divide that by 2. And so what's the deal, right? So the deal is that this is actually y equals sine of 2 times x plus pi over 2. Now see, that affects your phase shift. That's why we had to do that. So amplitude, what's the amplitude? It's just 1. What's the frequency? The frequency is 2. So now my period is 2 pi over 2. Remember, it's 2 pi over b. B is 2. And see, I can reduce, I can cross off those 2's. I can reduce it. So the answer for the period is just pi, right? And then phase shift. phase shift is going to be, see, usually if it's the opposite of what you see. So what ends up happening, right? The opposite of plus pi over 2 is minus pi over 2, and that's what I put there. Again, I've seen plenty of people make that mistake. You do the opposite, and then d is nothing, so I'm going to put na. I'm leaving the first one for you. All right. So now we're looking at changing degrees to radians and radians to degrees. Let's see. Hmm. Don't I got that? Yep, here we go right here. You can use the unit circle to find either sine or cosine. Yep. Let's see. Converting radians and degrees. So degrees, degree is supposed to be degree measure to radians. So I take the degree and I multiply it times pi over 180. And then radian measures to degrees, I take the radian measure, some number times pi or some number divided into pi or something, right? Matter of fact, let's make that a little truer to form. So that's going to be pi over theta times 180 over pi. So those are the formulas that I use. So I've got negative 300. So negative 300 times pi over 180. So that's going to be negative 300 over 180 times pi. So now I just reduce negative 300 over 180. So what number goes into 30 that also goes into 100? Well, excuse me. What number goes into 300? Negative 300 that also goes into 180. Well, it's like I was telling you earlier that ending in zeros means turn it off. So if the last digit is 0, I can divide by 10. So I'm divide by 10. And so dividing by 10 gets rid of those two zeros. So now I've got negative 30 over 18. So I think what number goes into 30 and what number goes into 18? Well, they're both even numbers, so 2 goes in there. If I try the 3 trick, 3 plus 0, that's 3. 1 plus 8 is 9. That means they can be divided by 3. So 2 and 3 work. So if 2 and 3 work, that means 6 works. So I'm going to divide by 6. So negative 30 divided by 6. See, the thing is that negative doesn't go anywhere. So that's why, battery's running low. Where's my, come on, we got stuff to do. There we go. Okay. So, as I was saying, I'm going to say negative 30 divided by 6. That's going to be negative 5. Then I've got 18, so positive 18 divided by 6, that is 3. And then I got to bring the pi along for the ride. That's my answer. Negative 5 pi over 3 or negative 5/3 pi. Either one, either way, did you say it or write it is fine. So negative 5 over 3 pi, negative 5. Turn it off. Just turn it off. You don't got to worry about it anymore. Turn it off. Just love being a parent. So next, if I have something that is bigger than 360, in order for me to find, I'm sorry, this that's something else. So what do I got to do? I'm doing the same thing. I got 870 times pi over 180. So that's 870 over 180 times pi. Well, again, like we did over here, we can cross off the zeros because that's dividing by 10. So we can start by dividing by 10. And then they're both not even numbers, so that's not 2. 3, 8 plus 7 is 15. That works. 1 plus 8 is 9. That works. So I can divide by 3. So 87 divided by 3, let's see. 8, 3 goes in there 2 times with, whoop, let's do a color you can see. So 3, why am I saying this when I could just do it? So 87. 3 goes into 8 2 times, that's 6. With 2 left over. Bring down to 7. 3 goes into 27 9 times. So that's 29 on the top. And then 3 goes into 18 6 times. So that's 29 over 6 times pi, or 29 pi over 6. Either way you say it is fine. Again, if you start with a negative, the negative doesn't go anywhere. So the negative stays. I'm going to leave 540 for you. And then we're going to go over here and do radians to degrees. So I've got negative pi over 6 that I have to multiply by 180 over pi. Well, see, because I'm going from radians, which has all these pi symbols in it, to degrees, which don't, see those pi's cancel each other off. So now I just got, that would be negative 1, and that would just be positive 1. Negative 1 times 180 is negative 180. And then I've got 6 times 1, that's 6. And then I just divide. How many times does 6 go into negative 180? That's negative 30 times. Done. Now, this is something that we were saying before, that if I'm looking at pi over 6, I don't know why this is looking so blurry. Ah, there we go. See, pi over 6 is right here, 30 degrees. I can use the chart for that. 3 over 4 is 135. Yep, that works. I'm not going to make a big deal if you don't put the degree symbol, but you know. And then 10 over 3 is not there. So see, 10 over 3, that means I just got to follow the formula. All right. Now, I'd appreciate you trying this without using a chart and doing that. I think it's worth the effort. But I'm going to do this one for you. 10 pi over 3 times 180 over pi. The pi's cancel each other off. And I've got 10 times 180 divided by 3, or I can cross cancel, divide by 3 here and get a 1, divide by 3 here and get a 60. And so now I just got 10 over 1 times 60 over 1. And 10 times 60 is 600. Done. So that's those. Let's see. And page 5. So now, here is what we were talking about. Right. There we go. Yep, there we go. So I can use this chart to find what cosine of 315 is, or sine of 7 pi over 6 is, right? So, like I said, there's some that I put on the notes just to give you a couple more examples. But here, so I need to find sine of 150. If I remember correctly, sine of theta is your second coordinate. Cosine is your first. So looking at these things. The first one is cosine, the second one is sine. So I'm going to be looking at the second one for this one. Right? So 150. 150 is right here. So I look at the second one. That is positive 1/2. Done. I'm not going to do that one. I am going to do this one though, because 675 isn't on here. See, the thing is, this circle is 360 degrees. This is what I was alluding to earlier that I had to stop myself. So I actually say it right here. Right? Oh, come on. Making me look bad here. Okay. So if I have something that's bigger than 360, what I need to do is I need to subtract 360 until I get a value that is below 360. So I subtract here, I get 5, 1, 3. 315 is smaller than 360, so I can find 315 on this chart. And I'm looking at sine. Sine is the second value, and I believe it is negative. It's hard to tell. Yep, that's a negative. So this one's going to be negative square root of 2 over 2. And that's the way you would work E. And I'm leaving E for you. All right, so the next one we're doing cosine. So cosine is the first value. So 7 pi over 6. Look for 7 pi over 6. It's right here. And I'm going for the first value. So that's negative square root of 3 over 2. And then 2 pi. Well, 180 is pi. 0 obviously 0, but so we go to 180, that's pi, and then we go all the way to 360, which is ending at the same spot as 0, so it has the same values as 0. So I want cosine of 2 pi. Well, cosine is the first value, so that's 1. So like I said, I'll leave these two for you. And now we talk about some probability. All right, probability. Sorry, I thought I just heard a fly. Okay, so probability of an event is shown by using P, right? So P of A means probability of event A. And that is just the number of ways things can happen, divided by or over the total number of things that can happen. So I got two spinners. They're at the right, they're spun. What is the probability of 2 or B? Well, what does or mean? Have we done that? Well, let's keep going. The probability of P of A or B. When you're looking at ors, that is just one event. That's not two. That is saying I want this or this to happen. And so, but that still is just one thing happening. It's not like I have one event and then the other. No, the or is saying for my first draw, it's either going to be this or this, right? So that is, you just add the two together. So I need to get the odds of the first thing, which is 2, or which the choice is 2. So the odds. Sorry, I didn't need to say odds. The probability, odds, same difference. So that's going to be 1 over 8 because there's 8 possibles, only one that I want. And then I've got the second event that is B. There's two B's over 1, 2, 3, 4, 5, 6. Now, I told you that I believe that you should reduce these if you can. That makes things easier on you. But here's it does make things easier on you, but in adding fractions, you could argue that maybe it doesn't. So I've got 1 over 8 plus 1 over 3. I think it does make things easier regardless. I need to find a common denominator. I need to find a number that goes that 8 can go into and 3 can go into. Well, there isn't one. I mean, excuse me, there isn't one that's smaller than usual. Yeah, sorry, my wife just walked by again. I had to stop for a second. Okay, okay. So anyway, so I got 1 over 8 plus 1 over 3. What you can always do to find a common denominator is just multiply your denominators times each other. So let's find a spot. 8, 1 over 8 plus 1 over 3. If I take 8 times 3, that's 24. Guess what? That is a number that 8 can go into and 3 can go into. So that's my common denominator. So I'm going to change both of my fractions to have 24 on the bottom. So to get 8 to have 24 on the bottom, I'm going to multiply by 3. But I got to multiply the top by 3. So that's going to be 3 over 24. 8. In order to get 24, using 3, I got to multiply by 8. So then I got to multiply by 8 on the top. So that's what's going to happen. So that's going to be 3 over 8, 24 plus 8 over 24. So that's going to be 11 over 24. That's my answer for the first one. Now, the next one is find the probability of this and that. So see, an and is I want to get the first event, then the second event. So those are two different events, and I'm going to multiply those together. So what is the probability of getting an even number? 2, 4, 6, 8. So that's 4 out of 8. That can be reduced to 1 over 2. I like putting the first event and second event like this, and then I deal with the addition, multiplication, or whatever. That's not necessarily what you have to do, but that's what I do. So now I need the second event. The second event is C. Well, there's only one C, so that's going to be 1 out of 6. So now I've got 1 over 2 times 1 over 6. That's multiplication, 1 over 12. Done. So let's see. Did I give you an or over here to do? I don't think I did. So let's give you an or just so you can practice later. How about I say with these, we say we want, how about we say an even probability of even um, or A. So I want you to try that for this and see what you get. Okay. All right. So next, greater than 5 and not C. All right. So greater than 5, 6, 7, 8. So that's 3 over 8 for the first one. And then not C. That's 1, 2, 3, 4, 5. The second one is 5 over 6. There's no reducing to do separately. But if I got 3 over 8 times 5 over 6, I could do some cross canceling here. But for the sake of argument, I'm not. That's 15 over 48. Now, are they both even numbers? Nope, they're not both even numbers. Next, see, they're not both even numbers. Can 3 go into them? So 1 plus 5 is 6. Yep, that works. 4 plus 8 is 12. Yep, that works. So I'm going to divide that by 3 on top and bottom. 15 divided by 3 is 5. And 48 divided by 3, that's 1. 1 left over, that's 16. So that's 5 over 16. Now, just for giggles, if I would have cross-canceled, I would have divided by 3 and got 1 up here, divided by 3 and got 2 down there. 1 times 5 is 5. 8 times 2 is 16. Bada boom. Odd and not B. I think what we're going to do is we're going to say this is odd or not B. And we're going to work that out. So what's the probability of getting an odd? 1, 3, 5, 7. So that's 4 out of 8. And that can be reduced to 1 over 2. And so not B. So B has got 2. So that's 1, 2, 3, 4. So the second event is 4 over 6, which those are both even, so they can be reduced to 2 over 3. So I've got 1 over 2 plus 2 over 3. So I need to think of what number can 2 and 3 go into. What number can 2 and 3 go into? Let me give you a hint. And I'll leave it at that and let you guys work that out. Let's see. I'm running out of time here. Okay, let's move this out the way. All right, let the event less than 6 on the first spinner and A on the second spinner be S. So what I'm doing there is I'm just giving it a label. Okay, so I can say, what is the probability of S? So less than 6. Well, if 6 is, let's move these out the way. Getting in the way now. I want less than 6, right? So less than 6 is 1, 2, 3, 4, 5. So that's going to be 5 over 8. That's my first event. And on the first spinner, and then A on the second one. 1, 2, 3. That's 3 out of 6 for the second event. So that's 3 out of 6, which reduces to 1/2. So I need the probability of that happening. So because those are just one event and any other, that they're multiplied. So 5 over 8 times 1 over 2. That's going to be similar to what we just did, right? That's 5 over 16. So the probability of S is 5 over 16. Now let's read the rest of the problem. What is the probability of the complement of S? That's why we gave it a label, because we're talking about complement. All right. So we can say, um, what is not C, or what is not B? But what you're not really gonna say in this instance is what's the complement of C, because that doesn't really fit that well. But if you give your probabilities events or event a label, and then we say what's the complement of that label, that's more so how it works. So that's why I gave it a label. We're calling it S, not 5, but S. And so the probability of S is 5 over 16. So now we got to deal with the complement. So the complement of probability, that is this page right here. So the complement of an event is all other outcomes, not the ones we want. So P of A prime, or that little hash mark, is the probability of the complement of event A. Complement of an event is all outcomes that are not the event. So I want the numbers that are not less than 6. So I'd want all the numbers that are more, right? And then I'd also want not A, I'd want B and C. So in all honesty, you don't have to get too technical with that. I want to know what the complement of S is. And so the way you find a complement is you take 1 and subtract the probability of your event. So the probability is 5 over 16. So I need to say 1 minus 5 over 16. Well, 1 over 5, or 1 minus 5 over 16, I need a common denominator. So I'm going to choose 16. So that's still 5 over 16. 1 is going to have the same number on top and bottom, so 16 over 16. And so 16 minus 5 is 11, and then 16, the common denominator, stays the same. You do not subtract the bottom numbers. It's not 16 minus 16. That is your common denominator, and it stays. And that's your answer. If the probability of S is 5 over 16, then the complement of S, the probability of the complement of S, is 11 over 16. Okay? And that's that. All right, so then we're going to finish this last little bit up, and then we'll call it. Okay, what is the probability of the spinner landing on C? Well, we've got 8 possibilities. There's only one C, so that's 1 over 8. This should be cake for you. What is the probability of not spinning C? Well, there's 7 other ones, so that's 7 over 8. What is the probability of the spinner landing on A or B? Okay. The thing is, see, I can count what's going on here instead of adding them, but I'm going to do both. So 1, 2, 3, A or B, there's 3 possibilities. That's just 3 over 8. Now, if I do it the way we did before, instead of counting, the probability of getting A is 2 over 8. The probability of getting B is 1 over 8, and I add them, 3 over 8. Boom. What is the probability of the spinner landing on one of the first 5 letters of the alphabet? That's A, B, C, or E. So it's not F. So that's just 7 over 8. And are you more likely to spin a vowel or a constant? Well, if I look at what we got, oh, okay. So if I look at what we got, let's count the vowels. I've got 1, 2, 3, 4, 5. There are 5 vowels. Count the consonants. B, C, F. So 1, 2, 3. There are 3 consonants. So what is it more likely to get a vowel or a consonant? It's more likely to get a vowel because there's more vowels. And that's that one. We're gonna stop this one and come on. Oh, didn't need to do all that. I just want to stop the video. Come on. There we go. Stop.